Hey everyone, welcome back, and today let's solve Leetcode problem 3375 titled Minimum Operations to make array values equal to k. So we're given an integer array nums and an integer k, and an integer h is called valid if all the values in the array that are strictly greater than h are identical. In other words, that really just means that there's exactly one value, one distinct value in the input array at that moment that has a value greater than h, and that is strictly greater, that is. So not equal to, but just strictly greater. So for example, if the input array nums is 10, 8, 10, 8, a valid integer would be h equals 9. Why? Because there's only one distinct value in the input array nums that actually has a value that's greater than 9. In this case, that's 10, right? Although we do have a frequency of 2 for 10, it is only just that one value of 10. 10 is going to be that distinct integer that has a greater value than 9, or our h value in the input array, and so that's going to be valid. And they also give us a counterexample where 5 would not work. Why is 5 not valid? Well, because we have two distinct values that are greater than 5 in our input array nums. We have 8 and 10. We only want one, i.e. we only want basically one identical value to be greater than h. So we're allowed to perform the following operation on the input array nums, where we select that integer h that is valid for the current values in our input array nums, not basically what they are at the current stage or iteration, and for every single index where at that index nums is greater at that index than that h valid value, we'll just set it all to be h, meaning we'll just take all of the values that are distinct, that are greater than h in the input array nums at that moment, and set them all to h in that singular or one operation. And we want to return the minimum number of operations required to make every element in the input array nums equal to k. However, if it is impossible to make all the elements equal to k, we want to return -1. So let's see how that kind of plays out and when we have to worry about that case. So in example 1, we have our input array nums to be 5, 2, 5, 4, 5, and k is equal to 2. In this case, the reason why we have an output of 2 is because that is the minimum number of operations that we can make so that all the values or elements in this input array nums are exactly equal to 2. How would that work? Well, in our first iteration, or our first operation, if you will, we'd make our first kind of valid element to be 4. If our first valid element is 4, well, let's think about it. We have exactly one distinct value in our input array that has a value greater than 4. It would be 5, right? Sure, we have a frequency of 3 for 5, meaning we have 5 occurrences, or 3 occurrences of 5 in the input array nums. 5 is still that singular distinct value that has a greater value than 4. So we'd select 4 to be our initial valid integer. We'd change all of these 5s to be 4s. Now we're only at one operation. Our next valid integer could be our k value itself, and 2, right? If 2 is our next k value, we change all the 4s to then be a 2, and that would be another operation, giving us all values of 2 in our input array nums after exactly 2 operations, right? So again, kind of a quick explanation. The operation is going to be performed in order using the valid integers 4 and 2 to get a minimum of just 2 operations to get all of the input array nums, or rather all the elements in the input array nums equal to 2, or our k value. In example 2, we have our input array nums to be 2, 1, 2, and we have k to be 2. In this case, why is your output -1? Well, because no matter what we do, we can never get all of our values equal to 2. Because let's think about it. Whenever we have a value greater than or strictly greater than a valid integer, we can decrease its value down to that integer. However, there is no operation or no kind of property in this operation that allows us to increase the values of elements to or up until that valid integer. And so whenever we have a element in our input array nums that is smaller than our k value, since we know we can't ever increase values in the input array, we'd never be able to make it equal to 2. And so we always have an output of -1 because 1 cannot be increased to be a 2 no matter what we do. We can only bring the values down using our operations. And so whenever we encounter that, that's kind of a main observation to make, we have an output of -1. Finally, in example 3, we have our input array nums to be 9, 7, 5, 3, and k is 1. In that case, we have a minimum number of operations to be 4, right? The operations, look at this pattern here, can be solved using the valid integers 7, and then 5, and then 3, and then 1. Notice how we're always picking the second highest integer, taking the highest integer, bringing it down to that second highest integer, and keep continuously doing that until we get all the values equal to that k value, right? Now notice how all these values that we're trying to change or bring down to 1, all of them are greater than k. all of them are greater than k, and we're basically selecting as our valid integer in each iteration the second highest value to bring them down until they all get down to k. Right? We don't care about elements that are less than k, because at that point it'd just be impossible. We only care to change all the distinct elements that are greater than k, which would determine ultimately how many operations we even need to get them all down to k, which is the next main observation that we'll really have to make. Before we get into that, let me just gloss over the constraints here. So for the input constraints here, we see that the length of our input array nums is always going to be between 1 and 100. Any value and the k value is also always going to be between 1 and 100 as well. Which brings us back to that again main observation. That is that to minimize the number of operations, like we saw in all three examples here, of course with the exception of example 2 because it was impossible, we always choose the second highest unique value in the array as our kind of valid or h value at that iteration, right? Because we're always ensuring that we reduce the largest value to the next largest value in that iteration, and we're gradually bringing down all those elements down to k, because again, we can only have that one singular distinct element in our input array nums be greater than our k value, or rather our h value that we select in each iteration or each state. So how are we going to kind of boil out or pan out our solution using that knowledge? Well, first of all, our first pass of our iteration, or pass of our input array should even check, okay, do we have any values that make our solution impossible, i.e. they have a value less than k? Because again, if we have any elements in our input array nums that are less than k, we already have an automatic impossible input, because we cannot increase their values, we can't do anything about that, we have to immediately return -1, right? If we don't have any values like that, well then we have to actually identify all the unique values that are greater than or equal to k. These are all the values that we have to actually minimize, that we have to actually decrease in value to gradually bring down to k in each operation. These are the values that we really care about that contribute to the minimum number of operations that we have to actually make, because each unique value represents a potential step in our operations, right? So we're going to basically collecting all of the unique values, basically the number of unique values that is in the input array nums that are greater than or equal to k. That's on a high level rundown how we're really solving this problem. And to actually count those operations, that's basically going to be the number or the count of those unique values, right? So let's go ahead and get into the code here. So what I'm first going to do is actually get that first pass out of the way. Is our input array kind of impossible? So how is that going to work? Well, let's just regularly iterate over our input array nums for num and nums. If any value num, any element if in the input array nums, if it's less than k, we automatically know we have to immediately return -1, making it impossible, because we know that we can't increase any values, we can only decrease them, and so we automatically return -1. It's impossible to make all the elements equal to k if we have even just one singular element that is less than k in our input array nums. However, if we pass that solution, we haven't returned -1 yet, that means we actually have a valid possible solution, and this is where we actually get the count of the number of unique values that are greater than or equal to k, i.e. the number of operations that we have to make to get all the values gradually down to k, which is exactly what the operations and the problem statement is telling us to do. So before that, let me just quickly initialize that unique values set, and quite simply here, as the name kind of suggests here, this is really just a set to actually store all the unique numbers that we see as we iterate through the input array nums. So let's iterate over the input array nums and build that value or that data structure here. So for every single number in our input array nums, if the number is greater than or equal to k, okay, well, we have to really worry about this. This is a value that we want to kind of gradually decrease. This is a value that we want to change to get all the other values equal to k, right? So as we find this, if any element is actually greater than or equal to k, we'll then actually add it to the unique values set. So unique values dot, I don't think it's add, I think it's append, or rather add in Python here, the current element num, because it is actually greater than or equal to k. We do care about it, and so we have to add it because we actually want to decrease it down to k. And again, why are we using a set? Well, because we really only care about that distinct element. We only want to keep our unique numbers, and sets are a great way to do that. Right? So once we actually store all of the unique values that we really have to potentially change in operations that are greater than k, we want to return the number of unique values that we find. And a very simple way to do that is the length of the unique values, because that's going to store the number of unique values that have a value greater than or equal to k that we have to actually gradually change in each operation to make them equal to k, like we saw in example 2, or rather 3, right? All 4 of these values were greater than 1, and since we have 4 distinct or unique elements or values in our input array nums that have a value greater than k, we have an output of 4. Going back up here, since we have exactly 2 distinct elements, that is 5 and 4, that have a value greater than k, which is 2, strictly greater, that is, we have an output of 2, right? And so we're going to return the length of the unique values, but this is actually 0 indexed, right? This is 0 index, and more importantly, we have to actually account for that fact that the last unique value doesn't require an operation because we don't need to reduce itself. We need to reduce 2 to 2, for example, and so we're actually going to return the length of the unique values minus 1 to get the accurate number of values that we need to change to get all of them down equal to k. So unless I made any syntax errors here, there should be accepted, and this should be a valid solution. So to kind of reiterate what we're doing here, before, let me actually make sure this works. Unique value, sorry, looks like I forgot an S here, sorry about that. Now, it should work now. Let me just quickly reiterate what we're really doing here, why we have that -1. Okay, probably just a very silly error on my part, sorry about that, guys. Okay, let's see what I did wrong here. If num is greater than or equal to k. Okay, in fact, I don't even think we need this -1. Unless I made a little error here. Let me just quickly double check here. Feel free to just fast forward this part, guys. This is just me having a very silly mistake here. For num and nums, if num is less than k, we want to immediately return -1. Then we want to begin our processing. So I don't actually know why this doesn't work at the moment. It's quite weird. Unique values that add num. Length. Okay, so yeah, so I don't know why this isn't working. I guess what I'm going to do is show you guys a really quick other solution here. And the way we can do that really is look at a scene set. We'll iterate over every value in the input array num. So for num and nums, if num is actually greater than or equal to our k value, and num is not seen before, so it's not in the scene set, meaning it's still a unique value, we'll increment the number of operations we need, so I'll just call it result, by 1. And then we'll actually add to our scene set the current element itself that we just saw. This is another way to do it. I don't know why the other way wasn't working. Well, actually, and let me just quickly initialize res here to be 0, and we're going to eventually return res. But that's only if our solution is valid. How do we know if our solution is valid? Well, we know that our solution is valid if even the minimum of our input array nums, even that is greater than or equal to k. Otherwise, if it's not, we return -1, indicating that it's impossible. So this should actually work now. Sorry about that, guys. Let me just quickly see. Okay, sorry. There should just be num. Sorry about that, guys. Now this should work. Sorry for the quick little errors here. Let's go ahead and double check. Okay. Yeah, so I don't actually know why this isn't working. I'll kind of quickly just post out a kind of main solution once I get this to work. Sorry about that, guys. But yeah, that's kind of the main solution of this problem. Really, we really just have to collect all the values that are the number of unique distinct values that are greater than or equal to k, and kind of just that's our output. So if you guys enjoyed this solution and learned something new, and kind of just quickly getting into the runtime complexity here, they're both going to be linear, right? Because of course we're using a scene set for our memory space complexity, which at worst case stores all the values, and our runtime complexity is big O of n. Why? Because we're iterating over each solution, or rather each element exactly once. Technically twice if we use a previous solution. I don't know why that wasn't working, but on average big O of n, or linear for both the runtime and memory complexity. So if you guys enjoyed this solution and there's something new, please consider liking this video and subscribing to my channel. And without further ado, I'll see you guys in the next video. Bye bye.